Hey guys, welcome back. So in the last video we talked about different types of linked list where we saw there are four types of linked list, that is single linked list, circular single linked list, double linked list and circular double linked list. Hope everything was clear. So in this video let's talk about why do we need so many types of linked list. So let's get started. So starting with the first type of linked list, which is circular linked list, we saw that it is the most basic form of linked list which has a flexibility to add and remove any node at runtime. So this is our array and we saw that we have a problem in this array, and the problem is that if you want to add any new cell or remove any existing cell, we cannot do it at runtime. So we came up with an idea of linked list. So in case of single linked list, we were able to add any node or remove any existing node at a runtime. So that was again a very simple form of a linked list where each node had two elements in it. One was the data and the second was reference to the next node. And the last node was always pointing to a null, indicating that this is the end of a linked list. Now let's see a scenario where the single linked list will not be good enough. So let's say we are implementing this board game. So typically a board game has 4 players, and all that we do is first the player 1 plays his turn, then player 2 plays his turn, then player 3 and then player 4. Now once player 4 is done, the turn again comes back to player 1 and then it goes to player 2, player 3 and player 4, and then once again it goes to player 1. Now if you want to implement these players using a single linked list, then we have a problem, and the problem is single linked list can travel from P1 to P2 successfully, from P2 to P3 successfully, from P3 to P4 successfully, but it can never go back from P4 to P1 because the last node always points to null in its reference variable. Hence, it does not know where P1 exists. So to solve this problem, circular single linked list comes into play. So how will circular linked list solve this problem? Let's see. So as we have learned in our previous videos, a circular single linked list, the last node of it always points back to the first node of the list. So this is where the trick is. So let's say we have implemented our board game using this circular single linked list. So we see that we have 4 nodes representing 4 players, player 1, 2, 3 and 4. Now once player 1's turn is done, it goes to player 2, player 2 turns it done, then it goes to player 3, player 3's turn is done, it goes to player 4, and once player 4's turn is done, the control goes back to player number 1, and then again 2, 3, 4 and so on. So it keeps on rotating infinitely in a loop until one player is declared a winner. So I hope the use of circular linked list is clear. Now let's see the third type of a linked list. Now the third type of a linked list was a double linked list. So a double linked list, as we discussed, is characterized by when we can move in both the direction depending on our requirement. That means from a given node we can move towards back as well as front. Now is there any situation where we need this kind of a functionality? Of course yes. So let's say we want to implement a music player which has next and previous button. So as soon as we click on the next button, we should be able to access the next song in the playlist. Whereas when we click on the previous button, we should be able to access the previous song in the playlist. Now the next button can always be implemented easily using a single linked list. But if we want to implement the previous button, single linked list will not be able to help us much. So this is where the double linked list comes into picture. So a simple implementation of this music player using a double linked list will look like this. So we have a song 1, song 2, 3 and 4 in our playlist. Now as we can see that we can move from song 1 to song 2 and then from song 2 to song 3. So if we are currently at song number 2, we can access the next song as well as the previous song. So I hope you would have understood what is the use of a double linked list. Now let's see the last type of a linked list, that is circular double linked list. So let's say we want to implement an alt tab button functionality. So as we all know that when we click alt tab button in a Windows, we get to see all the applications which are open in this computer. So right now I have 5 applications opened, that is desktop, Firefox, Outlook, WhatsApp and Skype. So if I click on alt tab button for the first time, the control goes to desktop. Clicking on alt tab button once again, the control goes to Firefox. Then it goes to Outlook, then to WhatsApp, then to Skype, and clicking on alt tab button once again will take us back to the first application, that is desktop. Now if you want to implement this functionality using double linked list, it is not possible, because once we are at this last application, it does not know the address of the first application. So that loop or the circle will never be completed. Now this is where the circular double linked list comes in picture. So if we implement it using a circular double linked list, we can represent each application using a node over here, and once we are at the last node or the application, we know the address of the first node or the application, and hence we can go round and round in a circle. So from the last application we can go back again to first, second, third, fourth, fifth, then again to first and so on. So you see that this was such a big problem of looping indefinitely, and this can be solved very easily using a circular double linked list. So I hope you would have understood why do we need so many types of linked list. Now that is all for this video. In the next video, let's talk about how is linked list stored in memory. Thanks for your time. See you in the next video.